Hello and welcome to the presentation of Cyber Operations and Risk Management Briefing by Team UK. Before the summit, each nation has set up its own secure communications network. As summit events began, our team responded to anomalous network activity that was detected on the agency server. We just have been hit with a Reviton ransom attack. We are investigating into how the attackers were able to infiltrate the system and plant the malware. What current protections are in place for systems at the summit? What methods and procedures will our team be employing in response to the current attack? What is the plan if protection falls short? Software Development Lifecycle, or SDLC, is a framework that describes the activities performed at each stage of a software development project. SDLC defines the complete cycle of development, for example, all the tasks involved in obtaining the essentials required for the product maintenance. Purpose of SDLC is to deliver a high-quality product which meets customers' requirements and expectations. Software Development Lifecycle is a process which defines the various stages involved in the development of software for delivering a high-quality product. Its stages cover the complete life cycle of a software from the inception to retirement of the product. Adhering to the SDLC process leads to the development of the software in a systematic and disciplined manner. SDLC phases represent the process of developing software. A software lifecycle model is a descriptive representation of the software development cycle. SDLC models might have a different approach, but the basic phases and activity remain the same for all the models. SDLC phases. Number 1. Problem identification. At this step, input from all stakeholders, such as salespeople, customers, programmers, and industry experts, is sought after. Strengths and weaknesses of the present system are identified. What don't we want? Number 2. Planning. The goals of the new software, its cost, and resources are defined, and risk mitigation plan is developed. This phase also involves development of a software requirement specification document. What do we want? Number 3. Design. Design specification plan is created, and plan feedback from all the stakeholders is collected. How will we get what we want? Number 4. Building. The software code is generated. Let's create what we want. Number 5. Testing. Software deficiencies and defects, bugs and errors are identified and eliminated. Did we get what we want? Number 6. Deployment. Software is being used in a limited capacity, and based on a user input, additional adjustments are made. Let's use what we created. Number 7. Maintenance. During daily software operations, continuous improvements are made to match the real-life needs. Let's make it closer to what we want. Waterfall, V-shape, prototype, spiral, agile, and iterative incremental models, rapid application model or RAD, extreme programming or XP, feature-driven design (FDD), and dynamic systems development method (DSDM) represent some of the most common SDLC methodologies. Not every model fits all the projects. If there is nothing that fits a particular project, pick a model that comes close and modify it for your needs. Each team must pick or customize an SDLC model to fit its project. Ensuring supply chain will require a public-private effort to promulgate best practices and methodologies that promote integrity, security, and reliability in hardware and software code development, including processes and procedures that diminish the possibilities of erroneous code, malicious code, or trapdoors that could be introduced during development. Time of delivery and the cost are frequently named as primary risks associated with software development life cycles. However, system assurance remains the most serious in the context of software supply chains. In addition, Supply chain risks can be divided to the unpredictable risks that cannot be mitigated, such as epidemics, natural disasters, or terrorist attacks, and predictable risks that can be planned for, such as supplier disruption, theft, cybersecurity, software risks, and the others. Best practices for SCRM. Automation. In order to eliminate human error, data collection, management, and analysis should be automated. Early detection. Automation software must be able to detect errors long before they become a significant problem. Supplier transparency. Performance data from supplier should be easily accessible at all times. Classification. All potential risks must be categorized based on mitigation plans and most optimal cost efficiency. Collaboration. SCRM metrics should be available to all departments in order to gather their input and thereby increase SCRM efficiency. Leadership. SCRM should be overseen by one leader, preferably vice president, who may choose to delegate to a team. Monitoring. SCRM tools should be able to constantly identify new risks in order to improve their mitigation. Software assurance helps with the following: the definition of software requirements, software development lifecycle, and costs for security needs and expectations. Reduction of software and services costs with the rights to new software releases and cost-efficient upgrades. Use of consulting services to plan new on-premises deployments for better results. Improvement of operational efficiency. Increase of overall user productivity. Identification, analysis, and reporting as part of the risk management framework, authorization package within the software framework. Creation of information management model that outlines user, subsystem, and external system interactions. Assessment of information and the information system threats identified by a customer. And identification and analysis of potential threats and bad actors. A benchmark for measuring the maturity of an organization's software process. CMM defines 5 levels of process maturity based on certain key process areas, or KPA. Level 1. At the initial level, processes are disorganized, even chaotic. Level 2. At the repeatable level, basic project management techniques are established, and successes can be repeated due to predefined and documented processes. Level 3. At the defined level, an organization has developed its own standard software process through greater attention to documentation, standardization, and integration. Level 4. At the management level, an organization monitors and controls its own processes through data collection and analysis. Level 5. At the optimization level, processes are constantly being improved based on the feedback from current methods and introduction of the innovative procedures to better serve the organization's particular needs. Business continuity plan outlines the processes and procedures of the operations during the unplanned disruptions of services. The disruptions may be caused by natural disasters, software attacks, inside attacks, physical intrusions, lack of infrastructure, data breaches, and hardware failures. It is more comprehensive than a disaster recovery plan and contains contingencies for business processes, assets, human resources, and business partners, every aspect of the business that might be affected. Business continuity plan should be used as a guide in case of natural disasters or any other unexpected events that could potentially disrupt the daily operations of an enterprise. In addition, the plan should include event severity ranking, assessment of damage, methods of recovery, and the parties responsible. The software recommendations include the following guidelines. The software development process should adhere to the company security standards, Furthermore, the security standards should address product vulnerability to an unauthorized access, possible security incidents, malware risks, and any other threats to CIA triad. By dividing SDLC into multiple small cycles, Agile methodology will allow the company to receive immediate feedbacks from the testers and stakeholders, thereby increasing the efficiency of the product development. A realistic schedule goals and well-structured budget will ensure achievement of the milestones in a timely and the least stressful manner. In addition to ensuring trackability and legality of the process, the software documentation cycle will also allow to decrease dependency on the core development team. Early implementation of the quality control will ensure that the software code, design, and requirements are aligned with the preset product metrics. The success of the project should be measured through the capability maturity model, which will allow to track a maturity of the software development and to identify areas that may need an improvement.